All apprentices and delivery staff must wear PPE at all times in an official workshop. Note that these practical examples are filmed in a teaching environment.
Welcome to this video on safe isolation. In this video, we're looking at the requirements for safely isolating a three-phase distribution board and focusing in the basically requirements for the endpoint assessment of the AM2S. One of the first things you'll do with the AM2S is isolate your three-phase distribution board, and you can see that information in the free download of the pre-assessment manual for the AM2. You'll need to select from a range of instruments provided the correct instrument for carrying out safe isolation and testing the voltage. There are a range of different voltage indicators that are available, but the one you need to select must be compliant to GS38. Again, this is a free download available online from the HSE, and that goes through the requirements for test equipment. So we'll look at that as we come onto it. Also, you're going to need a lock-off kit, which are secure safe isolation on the chosen means of isolation. Safe isolation has to follow a specific procedure. The first step in this is to get permission from the duty holder or the owner of the installation to isolate their supply. Hi. Would it be okay if I isolated your three-phase distribution board? What's going to happen is all the circuits fed from this board are going to become de-energized.
Yes, of course.
Okay, thank you. Now we have the main switch in the opposition. The installation is actually now isolated. The next step is to make sure it stays isolated. So we need to fit some kind of locking device which is going to prevent somebody from switching the main switch back on. One used quite often in endpoint assessments would be this type of locking device, okay, which locks into the main switch and can take a padlock to prevent it being turned on. Inside the main switch, you'll find a couple of holes just inside there that locks into, okay, and then once a padlock is fitted on there, you won't be able to easily remove that. So we need to select a padlock that needs a unique key, so this can't be unlocked by anybody else. But we also need to inform anybody that this is switched off for a reason. So we need to fit a safety label as well, telling people not to remove the safe isolation. Try and position the label onto the lock so that it's visible, so you can see the front, so not to the back of it. Okay, and then we just place that through our locking device, and that's the padlock safely fitted, locking the main switch in the opposition. The last step is to make sure you retain the unique key, but now is the time to do that. So that needs to go securely in your pocket, okay, and then you keep that throughout. Okay, so there's the main switch now isolated. The next step we need to do is to make sure that the isolation has been effective. So we need to measure for voltage on the top of the terminals of the main switch. In order to do that, I'm now going to have to remove the cover to the three-phase board. With all the screws removed, we can now take the cover carefully away, passing the lock through the hole there. And now we have access to the terminals where we can test to see if it's live or dead. That can be quite tricky, getting that cover off with the padlock in place. So is it acceptable for you to switch the main switch off and then remove the cover and fit the lock afterwards? There's no right way of doing it. All that you can't do, you mustn't remove the cover without switching off the main switch. Okay, it's going to be live at the bottom here, or it is live at the bottom there. So now the next step is to make sure that this isolation has been effective. So GS38 has many different requirements, and for example, if we select this instrument, we can see that the leads on there are flash tested to 1000 volts, that there are finger guards, and that the tips of the test probes are retractable, or if we pull and turn those, we can lock these so that there is 2 mil of exposed tip on the ends of the leads. GS38 requires a maximum of 4 mil, recommended 2 mil. So this meter would be GS38 compliant. This meter wouldn't be, because the leads are not really rated for 1000 volts and the tips are far more exposed than the recommended 2 to 4 mil. This particular meter could be acceptable. The leads are okay. It's got the finger guards and everything else. But again, there should be some shrouds covering those probes for this type of testing that are not present, so we wouldn't be able to use that one. So this would be the right test instrument to select for the safe isolation. Okay, so having selected your test instrument, the next step would be to prove that they're in good working order. To do this, we're going to use a proving unit. It comes with this equipment. You can also use a known source of supply, but here we're going to use a proving unit, and you simply put the probes into the proving unit, and what you should see is that all the lamps come up to prove that the equipment is working correctly. Now we know that our test instrument is working correctly, we need to do our 10 tests for our 3-phase supply at the distribution board to prove that it's dead. So when testing for safe isolation, you need to test between all the live conductors and all live conductors to earth. So that would be 10 tests for a 3-phase supply. I'm going to do my own sequence where I start with testing between the live conductors, L1 to L2, 0 volts. L1 to L3, test number 2. L2 to L3, test number 3. I then move to the neutral, L1, number 4, L2, number 5, L3, number 6. Then move from neutral up to the earth, test number 7, and then L1 to earth, number 8, L2 to earth, test number 9, and finally L3 to earth, test number 10. Having completed all the tests, we then need to reprove our tester on the proving unit. So that completes safe isolation at a 3-phase distribution board. Just a handy tip for you, if you're being assessed whilst doing safe isolation, it's always a good idea to count out your 10 tests at the board, counting them 1 to 10. What that does is it tells you that you've completed all of the 10 tests. If you get to 9 and you think you're finished, don't try and guess which one it was you missed. Just start again from the beginning and make sure you go right through until you get all 10 tests in there. This method of safe isolation is correct for 3-phase distribution boards that have yet to be put into service. In other words, their final sub-circuits have not been energised or may not even yet be wired in, such as at the start of your endpoint assessment. However, you may have occasion to need to safely isolate a distribution board that is in service for purposes of fault finding, for example. If this is the case, then the safe isolation procedure actually remains pretty much the same. The only difference is really when you come to actually doing the switching off, so step 3. Before, what we've done was switched off the main switch because the rest of the circuits were not yet put into service. However, if it is in service, then what you must do before switching off the main switch is you must isolate all of the individual circuits before switching the load off from the main switch. So again, if you're isolating a 3-phase distribution board circuit, that's in service, before switching off the main switch, you must remove all the loads from that main switch.